As you simplify these, remember, among the rules we have for simplifying fractions is that we cannot leave a radical in the denominator. So rationalize the denominators here. Right, and to refresh your memory, make sure you're heading on the right track here. Remember that in order to rationalize the denominator, I multiply that by its own square root. So I'm going to multiply the bottom of this first fraction by the square root of 2. But if I multiply the bottom by the square root of 2, I of course also have to multiply the top by the square root of 2. Now when we do that, of course, on the top, 1 times the square root of 2 gives me the square root of 2. On the bottom, the square root of 2 times the square root of 2 gives me the square root of 4. But of course, what does the square root of 4 equal? 2. Because multiplying a square root by itself is like squaring it, which gets rid of the square root. That's why we multiply it by itself. No more square root. This then would be our final answer. It is root 2 over 2. And this can be the final answer because there's no more square root in the bottom. Alright, so then on to number 2. In this case, I got to multiply by root 5. And so you multiply top and bottom by the square root of 5. When we do that here, we end up with 30 root 5 over 5. But in this case, we're not done. Yes, I rationalized my denominator, but there's actually something else I can do. I can reduce the fraction. Specifically, in this case, you'll notice that the 30 and the 5, I can divide them both by 5. And so if I do the 30 divided by 5, that leaves me with 6. And so the final answer then is 6 root 5. Much simpler than what we started with, at least. And then for the last one, number 3 here. There's actually a couple different ways you could start, but I'm going to start this one the same way I started the others. I'm going to multiply top and bottom by the square root of 20. When I do that, I get 16 root 20 over 20. And at this point, you're probably thinking, okay, let's reduce it. And so, if we reduce it, these are the numbers I'm looking at. I'm looking at the whole numbers, the numbers that are outside the radicals. And so 16 over 20, I can divide them both by 4. And so that would end up giving me 4 root 20 over 5. Although the thing is that this one's still not done yet. Because you'll notice that the square root of 20 can also simplify. Remember how we simplify a square root? I look for the biggest perfect square that goes into 20. And so, thinking about what is the biggest perfect square that goes into 20? Yeah, it's just 4. And so I rewrite this then as the square root of 4 times the square root of, well, 4 times 5 is 20, so it's got to be 5 there. And the reason why I look for the biggest perfect square is because I can then actually take the square root of that one. Because the square root of 4, of course, equals 2. So this is 2 root 5. Now, if it was a 4 root 20 instead, like we have up there, that means I'm doing 4 times all of this stuff. So it's going to be 4 times 2 root 5. So it's actually then the top of my fraction is going to become 8 root 5. So I now write this as 8 root 5 over 5. Now, can this reduce any further? Well, some people end up looking at it and saying, well, I got a couple 5s there. Can't I reduce the 5s? And the answer there is no, because this 5 is trapped inside of a square root, and this is out of a square root. That makes them fundamentally different numbers. And so, no, I cannot reduce those 5s. And nothing else goes into the 8 and the 5. So, yes, this then is your final answer. 8 root 5 over 5. Now, this skill is something we're going to be using later on as we go through our work, because we are getting into trigonometry in this unit. And you're going to find that these skills of rationalizing denominators are going to come up a little bit here and there as we go, because we're going to be dealing with some exact values. Before we get into all that calculation stuff, though, let's make sure you remember this. Our definitions of sine, cosine, and tangent. Now, theoretically, you would already remember all this stuff from last year, but we can also be realistic. 1 unit of math does not mean you memorize everything from it for years and years later. So, if you don't remember this, go ahead and write down these notes, these definitions of sine, cosine, and tangent. Now, of course, you would add this into your notes if you didn't remember it, but last year you probably learned a way to remember these. A single word that is a way to remember sine equals opposite over hypotenuse, and so on. It's starting to come back, right? Do you remember SOHCAHTOA?
Yeah.
If not, it might also be worth writing this down along with the other notes that you had there, because it's a way to help remember sine, cosine, and tangent. The way that it helps us is that the S, well, of course, that's sine. And remember what the definition of sine was? Sine, that you just wrote down in your notes, sine equals opposite, the O, next thing in SOHCAHTOA, H, over hypotenuse. And so that then tells me sine equals opposite over hypotenuse by remembering that SOH. The next thing, the C. What do you suppose C stands for? Gotta be cosine. And AH, well, our definition of cosine is that it equals adjacent over hypotenuse. And so cosine equals adjacent over hypotenuse. And then TOA, T, of course, would stand for tangent. And we can use that to remember that tangent equals the opposite over the adjacent. And SOHCAHTOA then can be a way that will help you to remember those definitions. Now we're going to use those definitions in order to answer these 4 problems. This is going back to that work that we did last year, end of geometry type of stuff, where you could find the missing sides or angles in a triangle using sine, cosine, and tangent. So that's what we're going to do here. What I'd like you to do, please, is try to work each of these problems, but I will be going through each of them and demonstrating and reminding you how to do them as well, but try to do each one first. Even if I don't give you enough time to finish it. Try to do it first because that helps you learn and retain as we talk about it and demonstrate it. All right, so now we're going to take a look at that first one and see how the first one gets done, remind us of this whole process that's involved. The first thing I'll often do is actually label the parts that I know on my picture. So I know angle C is 70 degrees, and notice I know it's the angle because that's a capital C, and capital letters, remember, are always angles. Lowercase are always sides. Lowercase b is 10, so that tells me that that side length is 10, and I'm trying to find C here. And so those are the only parts that I care about. All the rest of them are not going to enter into this in any way, shape, or form. All right, the first thing I have to do is I have to decide if this is going to be sine, cosine, or tangent. And I do that by identifying what I call these 2 sides that I'm working with. Each of those is going to be called opposite, adjacent, or hypotenuse. Let's start with the 10 that we know. What do we call side B here? Well, let's see, as I look at it, it's the longest side. That could tell me. It's also opposite the right angle. That could also tell me the same thing. Either way you remember it, it should tell you that this is the hypotenuse of my right triangle. Because yes, it is always a right triangle. And then I'll go to C, lowercase c, the side that I'm trying to find over here. And so this side, what do I call that side? Well, it's got to be either the opposite or the adjacent, of course, because I already used the hypotenuse. Notice from side C, from angle C, it's always from the angle that we're given. From that angle, it's the opposite side of the triangle. It's literally like on the opposite side of the triangle from where that angle is. You could also remember the opposite as being the side that the angle doesn't touch. And so then that means that side C is called the opposite. That's enough now to know if it's going to be sine, cosine, or tangent. Which of those involves hypotenuse and opposite? Sine. And so I write sine, and sine always has to be of an angle. Now if I know the angle, I plug the number in. In this case I do, so I do sine of 70 degrees. If I didn't know what the angle was, I'd put in the variable for it here, because sine always has to be of some angle. And sine equals, my definition of sine says it equals opposite over hypotenuse. That means I have to write the opposite on the top The opposite in this case happens to be lowercase c. Over the hypotenuse in this case happens to be 10. It doesn't matter which one we know and which one we don't know. It only matters which one is opposite to go on the top and which one is hypotenuse to go on the bottom. Then we solve from here. And there's a couple different ways people solve these. One way is that you actually write it all as one big proportion. So you'd write like your sine 70 over 1, and then you could cross multiply. Or you could think of it as multiplying both sides by the denominator of the fraction, which is what I'm going to choose to do here. And it's always multiplying by the bottom of the fraction. Because if I do that and multiply by the bottom of the fraction, it cancels it out, because c over 10 times 10, it'd just be c. And then on the left-hand side, well, the 70 degrees, it is trapped inside of sine. I cannot change the 70 degrees. And so when I multiply by 10 over here, it's just going to be 10 times sine of 70 degrees. That's all I can do there. However, what this did do is it now gave me an equation that tells me what c equals. So now it's time to break out the calculator. And when you break out your calculator, the first thing we're going to have to do is make sure it's in degree mode. Now, once you think you've got it in degree mode, or if you're not sure what it is because your calculator is being a little extra complicated, there is actually a way you can check to make sure it's in degree mode. It's a value you are going to get to know well over this unit. Do sine of 30 degrees as a tester. If you type in sine 30 in your calculator, if you are in degrees, it's going to give you 0.5. So test that. Make sure that you can get 0.5 out of your calculator on this. All right, now that we know our calculator is in degree mode, we can go ahead and we can calculate this value. And again, depending on your calculator, will change how you type it in. If you are on a graphing calculator, yep, you just have to type it in just as you see it. 10 times sine 70 equals. If you're on a scientific calculator, typically you'll do it in the opposite order. You'd press 70, 7 then 0. Then you'd press the sine button, so that it's then telling you what the sine of 70 is. And then you would say times 10. And if you type that in on a scientific calculator, that should give you the same thing. All right, and when you do that, if all has gone well, you should be getting an answer of about 9.4. And this is an approximation of c because we had to do a little rounding, so I'm using the wavy equal sign to show that it's rounded. All right, now on to number 2 here. And again, I'm going to start the same way. I'm going to start by just labeling the pieces of my picture that I'm working with here. In this case, I know that angle A is 30 degrees. Side A is 14, and I want to find side C. All right, so I got to decide if it's sine, cosine, or tangent. That means knowing what I call each of these sides that I'm working with. I'll start with this one here. What do I call side 14? It's the opposite, yes. Because you notice it's on the opposite side of our angle. I'm always going from whichever angle I am either told or I'm trying to find. So that is the opposite. And what do we call side C here? That would be the adjacent, yes. And so then, if I'm involving O and A, is that sine, cosine, or tangent? It is tangent, yes. Because tangent is opposite over adjacent. So then, in my work, I write tan of the angle. Remember, it's always of the angle, whatever that happens to be. So tan of 30 equals, and tangent is opposite over adjacent. So that means I got to put the opposite on top. The opposite here happens to be the 14. And the adjacent goes on the bottom. The adjacent here happens to be lowercase c. And now I need to solve this. And my first step in solving it is going to actually be the same that I did last time. And that is, since my variable is in a fraction, I'm going to get rid of the fraction by multiplying both sides by the denominator. In this case, though, that means multiplying both sides by c. Well, when I do that, it gives me c times tangent of 30 degrees equals 14. Last time, after I multiplied both sides by the denominator, I was at my destination. I had c equals, but not so in this case. I got to do a little bit more work. Right now it's c times the tangent of 30. So I got to actually divide out the tangent of 30. So we divide both sides by tangent of 30 degrees. That always goes as one chunk. If I know tangent of the angle, I just leave it as tangent of that angle. I don't break apart the tangent and the 30 at any time. So when I do that now, I get c equals 14 over tan 30. Now that it's c equals, that's telling me that's what I need to calculate. So we can now go ahead and do that calculation, 14 divided by tangent of 30, to get the answer. And when you do that, you should be getting an answer of about 24.2. Right, on the next problem, number 3 here. Again, we start the problem the same way. I look at labeling the pieces I know. Notice I know lowercase b is 12. Lowercase a is 8, so that's side A. Remember, lowercase is always the side lengths. And I'm trying to find lowercase c, so I'm trying to find that. Notice what's not involved in this problem anywhere. There's no angle involved. Trigonometry depends on there being an angle involved in some way, shape, or form. So how could I find the missing value c? Because actually we still could do it. Yep, you could actually go back to Pythagorean theorem, and just because we know trigonometry, I don't want you forgetting that one. Yes, remember Pythagorean theorem, a squared plus b squared equals c squared. Remembering, of course, that here when I say c squared, what I really mean is hypotenuse squared. And so I could solve this here by turning it into 8 squared plus c squared equals 12 squared. Remember that the one that's by itself over here always is the hypotenuse. That's why it's the 12. The fact that I happened to be dealing with a triangle where some of them were named A, B, and C was irrelevant. And so, to do this work then, go ahead and square where we can. Then we subtract the 64 in this case, subtract 64 from both sides. And then we take the square root of both sides as well. And so we end up finding that c equals the square root of 80, which actually I wouldn't want to leave it that way. I would want to simplify that, because the square root of 80 is the square root of 16 times the square root of 5, so that would be the same as 4 root 5. All right, now our last example problem of those that we're doing today. Today being kind of this catch up and review, practicing what you did back in geometry kind of a day. I start this problem the same way. I label the parts of my triangle, and so I know little b is 9. I know little c is 4. And I'm trying to find angle A. Now notice in this case, because I'm trying to find an angle, yes, this problem involves an angle. And since it involves an angle, I am going to go ahead and still use sine, cosine, or tangent. Alright, so then, first thing I have to do is decide if it's sine, cosine, or tangent. And so I decide what each of these sides that I'm dealing with are called. Side B, that would be the hypotenuse. Side C, that is the adjacent. Because remember, I'm going from this angle up here. The opposite to angle A would be on the opposite side. All right, so if it's dealing with hypotenuse and adjacent, I go back to my notes and I remember, yes, that would be cosine. So it's going to be cosine of, and remember it always is cosine, sine, or tangent of the angle. I don't know the angle, so I'm just going to put the letter in for it. So it's cosine of A. Equals, the definition of cosine is adjacent over hypotenuse. So I'm going to write the adjacent number on top, that's 4, and the hypotenuse number on the bottom, that's 9. Now in this case, I don't need to multiply both sides by the denominator here, because my variable isn't in the fraction. My variable is inside of cosine. So what I actually need is some way to get rid of the cosine so that I can just leave the a behind. Well, there's actually a function for the inverse of cosine, conveniently enough called inverse cosine. It's written as cosine to the power of -1, but it really reads as inverse cosine. Remember earlier this year we saw inverses? We represented it as like f to the power of -1 is the inverse of f. This is why we have that notation for this as well. And so that cancels out the cosine on the left, leaving us just with the a. On the right, I then have to do inverse cosine of the 4/9. Now notice that since it is a equals, I can now actually do the calculation. So I'm going to calculate what is inverse cosine of 4/9. When you've done it, you should be getting an answer of about 63.6 degrees. And because this is an angle, yes, I go ahead and include the degree symbol here.